All right, guys, we're going to continue with the testing here. Put that to the side for a minute. I found another power supply. That other little one I had, it was only like 260 milliamps. So anyway, this one's only 1.5 amps. It's not much better. But if I put this to 65, which I have it at now, kind of dies. But if I go down to 50, you can see that. We get a nice spin out of it. It actually looks faster. This one looks faster at 50 than my old one did at 100. But anyway, I'm just basically losing the amperage, I think. So I have this guy here. I had a bunch of these, when I was building my CNC table. I was messing around with them. My problem here is that my voltage is very high. On the 220, 247, and, half of that on the 110. So I need the power supply. See how it says plus or minus 20%? I need that on the 110 because my 110 might end up being, 125 or close to it, right? 123.5, I believe. Let's just say 124, right? So 20%, give or take, over to 110. I should be okay with this guy. My problem here is fitting it in this box, but if I actually mount it vertical like that, I think I have just enough room to make my connections, and then I could kind of figure out how I'm going to screw it in this way and still be able to put the top back on. I also have the solenoid in there. I'm going to go out this side. That'll connect to the tank, and then come out the front with the rest of these, and that'll go to the gun. The next thing I dug up was a little on-off toggle switch. Nothing crazy. What I'm going to do here, guys, instead of running a solenoid so it works on and off with that switch, I'm going to actually put it right on the back side here with a separate toggle. And hopefully that makes sense. What I'm going to try to do is turn on the gas a second, just the time it takes to flip this toggle, and then go over to the front to grab the trigger. I'll basically cover the area so I'm not contaminating the start, kind of like TIG welders do. But I've never had this feature on a MIG, so I'm trying to add it to this one. And then what I'll do is after I'm done, I'll just hold the gun there for a second, do a post flow, and then shut it off. And then that'll shut my solenoid off, and I'll shut down on the gas. But anyway, this was a good test. Like I said, I'm going to disconnect this now. I also have the fan. If you guys remember in my last video, the fan was bogging down and barely spitting. My motor here was bogging down. It just didn't have enough amperage. So this guy has, so it says 15 amps at the 12 volts. So I feel like that's really going to be the game changer here, guys. All right, guys, we got the toggle switch in. You can see you're going to be able to pull the trigger, and then just something like that on and off. Gonna solder these two connections. So this is what I used in the beginning, guys, just to run the little windshield wiper motor I got there. From whatever I could find online, I'm guessing this motor might draw 5 amps. I doubt even that much. So I basically found, it fell on the floor here, some of my old CNC cabling again. This is 18 gauge. So, and it's 4 pair in here. So basically I cut this back. I'm going to use the black and the red for the windshield wiper motor, wired into the switch, obviously. Then I'm going to use the green and the white for my solenoid valve and fan. And I think that should be fine. These are 18 across the pair. Top of my head, probably around 10 amps, something like that. 14 gauge is 15 amps, 12 gauge, 10 amps, and, as you get thinner, 16 gauge, maybe 18 amps. I'm sorry, I'm going in the wrong direction. All right, we got that soldered up. I definitely regret not putting some shrink wrap on this first. I don't love these two connections open like this, but it is what it is. I had made this hole a while back. This was actually a mistake because I had the handle mounted up there. I moved the handle back a little bit to get a little bit better weight distribution. But it looks like these holes are going to work out good for the holes for my switch, for the wires for the switch, sorry. So I'm going to leave this hooked up for now, just for my initial testing. Then I'm going to, cut these off, and I'll switch to the red and black up here. That's the end of the day for me, guys. Tomorrow, I got in the, I normally don't promote things I'm not sponsored by, but this is Blue Demon, they call it. We'll see if it works. It's the, not the aluminum bronze. It's the silicone bronze, guys. So I'm going to switch that out for the aluminum spool. Hopefully I got 035. Let's see. Yeah, 035, perfect. So I'm going to switch that out, and then my first project is going to be a cast iron vise that keeps breaking on me. I welded it with the regular MIG years ago, and it held up for a couple years, and it cracked again. I welded it. Each time it seems like it's cracking faster. Supposedly, according to YouTube, this stuff is supposed to be great for cast iron. So I'm going to make that the first project. Hopefully tomorrow I'll get power supply in. I found these little tiny screws. That in itself was a crazy project, but luckily I keep all kinds of little crap. My buddy Giuseppe got these years ago for me. Yeah, so I got the power supply mounted. I'll run the tubing for the solenoid, and I got everything wired up. We should be good to go. Alright guys, so I'm not sure what I had said a couple videos back. I think I forgot to press play on one of the videos, but let me do a quick recap. I have this power supply. They both will take 110, and then I have a 20% differential on this one, but this one's 15 amps. I don't think I need all that. I'm about 2-3 amps on the motor, maybe another amp with the fan and the solenoid. So I found this little guy. And this little guy is 5 amps, 110 with a 15% differential. When I figured that out, it was like 126 volts. So when I checked my outlet here, I was at 123. So I'm getting close, but I should be all right. I know I got a bird's nest of wires here, guys. Basically, you run the mains in. I got my hot, neutral, my ground on the left-hand side of these power supplies. And then the far two right are DC positive. The next two over are DC negative. What I did was I gave these two on the fan, and then the other two I ran for the solenoid and for the motor. I have my switch wired in now. My front switch operates the motor to push the wire through. My back switch is for my argon gas. So, obviously I did this before. I know it works, so I don't look like an idiot. But we'll plug that in. We get the green light on the power supply. And the digital tack lights up. It's on already. Now we come over here. And we have nice movement. We're at 50%. Now, getting ready to weld. I put my argon on. Should hear this click. There we go. Solenoid, we have gas flowing. Do my weld. Done with the weld. 1, 2, 3. Shut it off. That shuts my gas. Now, with my last, a little power supply, 1.5 amps, when I would get up, around 65, it was kind of dying on me. So, let's try this. That's beautiful, guys. All right, keep jumping up a little bit. Let's try 75%. That's great. Forgot, fans on, blowing away, beautiful. Now let's just go right to 100, guys. We'll max it out. Before, I didn't get anything at 100. Oh, man, is that nice, guys. All right, we're never, ever going to be welding at that speed, but it's good to know that this power supply has plenty of amperage for everything. Tomorrow's another day. I'm going to clean up this disaster of a mess with the wiring. And I ran, you can see a little grommet there for the 4 pair of wires. I got to do the same thing for my vinyl coming in to this guy, and I got to mount the power supply vertically on the left, and then yeah, we should be done after that, ready to weld. One thing I wanted to change, guys, I had this front piece mounted like that. It was just hard mounted to the aluminum, and I'm trying to figure out a way to get the power cable connected here. Obviously it would be super easy if I could just connect it in the back somewhere, up here, over here, something like that, and just have the cable come down with the rest of them. My problem with that is I'm energizing the whole top piece here, and when I pull this trigger here, I might end up touching the metal, and you know, really don't want to be doing that. Probably give myself a nice shock at some point, or if you know I end up touching this to metal, you know, it could spark. So anyway, I definitely wanted to start giving myself a little more room. Things were getting kind of tight in here, so my idea was just to bump this out a hair. Well, I'll flip that over the right way. Just go from here to here, bump it out, and what I'm gonna use is a piece of this plastic I have. It's about 1/4 inch. Kind of made my design and how I want it to look. I'm gonna utilize these 2 original holes, and I'll probably add another 2, so I'll have 4, and then come out and tie back into these 2, and you know, I'll just have the spacers like I had originally. I'll just have to make these longer. And then my idea for the power cable, I'm using, I think this is 2-auge. Yeah, see if you guys could see that. So I'm using 2-gauge wire here, which is super gigantic for this, guys, but it's what I had, and this wire is very flexible. I do have some 4-gauge, which would probably be a perfect fit for this, or even maybe a 6-gauge, but it is a stranded wire, but it's really stiff, what I have. So I didn't want to use that. I'm going to use this for now, and then I'll probably just order something a little more manageable, but you know, I'm trying to keep the costs down as always. Anyway, so I'm thinking I might be able to get this guy in there and have it not really interfere with my argon switch, my trigger switch. You know, coming up on top here, I put all this in the way now, so I can't run that there anymore. I could possibly run around the back side also. So, you know, I got to flip this thing over and see what that looks like. But anyway, I'm going to pop out in the front. Trying to do this one-handed as always. So then when that's there, you know, maybe I'll just build a bracket right off of these 2 bolts, come down and just tie right into that. I think that'll be the easiest solution for now. Super excited, guys. I finally got this damn welder running. I'm going to show you guys in 2 seconds. I'm going to try to set it up and show you with welding, but I did a couple of test pieces so far, and I've welded regular mild steel, galvanized mild steel, and stainless, and I'm going to show you the difference. Unfortunately, on the stainless, it almost has a little bit of a gold color to it, but it still looks really cool. The bronze color really comes out, though. Once I hit it with the wire wheel, the bronze color comes out really nice on the mild steel and the galvanized. And the cool thing, as you guys know already, on the galvanized, it doesn't take off the galvanized coating at all. So as far as I think, it shouldn't rust. But anyway, I'm going to flip the camera around. I'm going to show you guys what I'm talking about. Okay, sorry, the bench is a mess as usual, but I'm too excited. I got to show you guys this. All right, so here we have, this is a piece of 1/8 inch. You know, it's mild steel, guys, but, oh, actually, I did not notice this before. Okay, so if you ever try to just plain MIG weld mild steel that's been galvanized, you get this white powder. It's highly toxic to breathe, which is phenomenal because I didn't know this was happening. And what you have to do is basically it's going to ruin your weld on the top side. What you have to do is grind the galvanized coating off, and obviously wear a mask to do that. But then it can be welded pretty much just fine. What the silicone bronze does is it doesn't affect the coating at all. You could see it actually almost leaves like a layer of bronze even to the side of the bead. That one right there, I believe, was just a braze from years ago, you know, whatever this came off. These are the ones I did, and you can see they're bronze in color. I've been messing around with the heat, and I started to get a little better. I have an arc welder that I'm going to try to hook this up to next that has a variable knob, potentiometer on the power button. What I'm using right now, the old damn MIG, the potentiometer has just fixed settings, so it's hard for me to fine-tune the power. As you guys know, I put the variable potentiometer for the wire speed, so that's been great. A few other tips and tricks. I put a secondary argon switch, so when if I just pull the trigger to start welding, I won't have argon. I click the argon on, so I do get a little pre-flow, and then I wait a second after, shut it down. So I'm good with that. I'm not getting any porosity or anything like that. These welds are a little bit high, but this is also 1/8 of an inch. I have more power to go. I think I'm running out of wire speed. This motor's a 12-volt motor, and I'm running it on a 12-volt power supply, so I'm maxed out on what I could get. But I've had great luck in the past overvolting DC motors, guys. So I probably could go to a 24-volt power supply and get more speed out of this if I wanted to try that route in the future without redesigning this whole thing with the new motor. I went with this motor because it's pretty small, and as you could tell, this thing starts to get pretty complicated and heavy, but it's super fucking cool, guys, and honestly, I'm sure you could tell, I'm so excited. Anyway, so here, now this is just regular, it's just a piece of thick sheet metal, and here you could see, the weld laid in much better. I'm still not getting a great bead, but I'm getting it to actually adhere to the metal, and I'm getting the color I want. Now, when I'm done, it's like a dull color. Once I hit it with the wire wheel, now it's coming out this nice bronze. The problem with this one is if I leave the steel bare, everything's going to rust except for the weld, or braze, whatever you call it. All right, now, moving on to the stainless. I did screw up a little bit over here, guys. I forgot the argon gas I had off. So I was flicking the switch, nothing was happening, I didn't realize it. But anyway, once I got that figured out, I laid a nice bead in here, and I laid some beads here. Now this is about 1/4 inch thick, and it's still penetrating about the same as everything else. It's just not really sinking in. I went back and I kind of just filled all this in, and it came out nice. So my last test is going to be that vise I keep talking about, cast iron vise that I have in my shop next door. I'm going to start prepping that. I have to grind off the old welds that I did with the MIG welder, and then I'm going to try this stuff. They say that it's really good for cast iron, so that's going to be my first very practical test. I'm going to have to crank this up. I'll probably preheat the cast, crank up the welder as much as I can, or do what I said before. I'm going to switch over to my arc welder as the power supply. I think that'll give me better control, a little bit more amperage, and then I'm going to preheat the cast, finish my welds, and then I'll slowly post heat with like a heat blanket or just slowly pulling a torch away afterwards. But I'm super excited with this, guys. Oh, I forgot about the color. So as you can see, the differences here, this where my thumb is the beautiful bronze I'm looking for. This is almost like a metallic-y, like goldish purple. And as I'm messing around with it, I'm getting different colors. Oh, the other thing I wanted to try, maybe I could do this right here, guys. I have my little map gas torch here. I wanted to mess around with heating it a little bit. don't know. Definitely looks more gold now. So that one right there looks just about the most bronze out of the bunch. Let's see. Wow, what a difference. All right, that might be what I have to do, guys. Wow, look at that. All right, let me see if I can get this one to bronze up. All right, it was bronze, and then as it cooled, that one went back. So maybe it's a certain temperature I got to get. Not really sure yet. That's so cool. It literally turns bronze and then flashes purple and then goes back to almost like this metallic-y silver, which is still cool in itself, and it's a great weld on the stainless. I have no qualms with that weld right there. So if I was putting together a cone pipe or even a straight pipe on a 4-stroke, and I could get the bead, I'm having a little bit of a problem, like I said, keeping the bead straight. And I think it's just because this thing is so bulky. I have to really work on using 2 hands and locking down my work and everything. But I'm thinking, you know, finish my welds. As long as they come out all right, then just give them like, you know, one quick pass with the torch. How cool is that? It just changes right back. I hope you guys can see that. That is awesome.